Iowa State University Industrial Manufacturing System Engineering Capstone Project with PellaCorporation in the class IE441 in the fall of 2021. Group 3. That includes Cody Frame, Dakota Herr, Jesse Hupp, and Justin Mraz. PellaCorporation is a leading manufacturer of residential and commercial doors and windows. Since the company was founded in 1925 in Pella, Iowa, it has grown to 17 manufacturing facilities and 7,000 employees in North America. PellaCorporation has been leaders in innovation within the industry, creating new products and streamlining manufacturing processes. Pella Continuous Improvement Team came to us asking for our group to redesign their finger joining department. The department repurposes excess lumber produced by the cross-cutting saw in the upstream department. The 4-inch to 18-inch boards then get finger jointed, routed into each of them, and then pressed together to form longer, reusable lumber. The goal of the project was to double throughput per square foot, decrease or eliminate repetitive motion, and decrease the labor cost by 25% per linear foot.
Currently, the finger jointing department is comprised of automation as well as manual labor. Before the finger jointing department can begin work, the upstream department must produce the material. The chop saw department removes any defects from the raw material and sends it into the finger jointing department. This results in boards getting cut down to smaller pieces. From there, approximately 12 workers run the machines and handle the material as necessary. The raw material is loaded up and sent downstream to departments to be implemented into future products. The process works well, however, there is some room for improvement. Currently, the workers in the department face hazardous repetitive motions. These motions include extending the arms and bending of the torso. This is a concern from the department and is something our team would like to address.
The team used 4 methods to fully understand the current state of the finger jointing department. To determine the ergonomic stress on the production workers, a REBA analysis was conducted. It was determined that both sorting and unloading were high risk. The next step was to identify the movements throughout the work cell to identify any unnecessary equipment or movement. A spaghetti diagram was filled out for 30 cycles of the process. The team found that there was a lot of movement wasted by unjamming the machine and re-chopping the failed boards. Diving further into inefficiencies, a work sampling study was conducted to break down the time spent for each work task, as well as time spent doing non-value-added activities. After analyzing the results, the team found that the current loading operator is running at roughly 80% efficiency, with the main non-value-add operation being the unjamming of the machine. Lastly, the team built a model of the system based on the average board lengths, current cycle times, and current equipment, and ran a simulation in Simio to determine the true maximum output. With these results, the team realized that the current system was running at 25% of its actual capability.
Our solution consists of a new fully automated finger joining system, including a spin feeder and an auto stacker. The new system would replace 3 of the 4 current finger joining machines, and the new system would have the ability to run characteristic lumber at 100 lugs per minute and clear lumber at 200 lugs per minute, which is almost double the speed of the current machines max out at. The machine is equipped with a production monitoring system for improved throughput monitoring. Based on the run speed, the new system would increase the throughput of the finger joining department by about 102% each year, and the spin feeder and auto stacker would eliminate almost all repetitive motion done by the operators in the system, and it would reduce the cost of labor per linear foot by 78%. With this solution, all of the project objectives would be met.
Following the implementation of this project, the following financial impacts will be achieved. Doubling throughput. By doubling throughput, the company will save money by producing more product. Reducing the cost to produce each product will again save the company more money. Eliminating hazardous repetitive motion will support a positive work environment and help retention. Overall, this implementation will nearly double the initial investment after 5 years.